The objective of this lesson is to use visual fraction models to represent multiplication of a unit fraction multiplied by a unit fraction. In previous lessons, students have modeled and solved whole number by whole number multiplication problems. They have learned the appropriate terms for the numbers in a multiplication problem. The multiplier is the number of sets or groups. The multiplicand is the size of each set or group. And the product is the answer. Today, students will extend their knowledge to multiplying a unit fraction by another unit fraction and use models to prove their reasoning. Veronica has 1/2 of a sandwich for lunch. She only ate 1/2 of that. How much of a whole sandwich did she eat? Let's model the problem using an area model and use the multiplying unit fractions recording sheet to record our thinking. The problem states Veronica started with 1/2 of a sandwich. Start by drawing a blue rectangle and dividing it in half vertically. Shade in one of the portions red. The blue rectangle represents one whole sandwich, and the one red shaded portion represents the 1/2 of a sandwich Veronica started with. Veronica only ate 1/2 of the 1/2 of a sandwich she started with. This is shown by taking the red shaded portion and subdividing it into 2 halves. Shade in the box in the upper left-hand corner, or shade in just one of the subdivided halves. The whole sandwich is now divided into 4 equal pieces, and the portion that Veronica ate is represented as the one shaded piece in the corner. Veronica ate 1/4 of the whole sandwich. The math equation to represent this problem is 1/2 sandwich eaten of the 1/2 of a sandwich started with. Therefore, the equation for this problem would be 1/2 times 1/2 equals 1/4. The relationship between the product and the multiplicand is that the product is half the size of the multiplicand, or 1/4 is half the amount of 1/2. Students understand that when performing the operation of multiplication on whole numbers, the product is larger. But with practice, when multiplying by fractions, the product results in a smaller number. With this problem, the product is 1/2 the size of the multiplicand, or factor. This isn't a rule we want students to memorize, but rather experience to understand the role of fractions when multiplying. Let's try another problem. Holly has 1/3 of a yard of ribbon. She used 1/2 of that on a project. How much of a yard of ribbon did she use? Let's use an area model to visually represent the problem. Start by drawing a rectangle to represent one whole yard. Next, divide the rectangle into thirds vertically and shade in 1/3 red to represent the 1/3 yard Holly started with. Holly only used 1/2 of the 1/3 she started with. Divide the columns into 2 equal pieces in order to take 1/2. Shade in only one of the halves of the starting 1/3 column. The whole, or the 1 yard, is now subdivided into sixths. The portion of ribbon Holly used is represented in the single piece on the top left corner. Holly used 1/6 of a yard of ribbon. The equation to represent this problem would be 1/2 yard used of 1/3 yard started with is 1/6 of a yard. Then 1/2 of 1/3, or 1/2 times 1/3, equals 1/6. The product is smaller than the starting amount, or 1/6 is half the size of the initial 1/3 starting amount. Looking back at the previous 2 problems where both factors were fractions less than 1, the products were smaller than the starting amount. The product's denominator was also a different denominator than either factor. The product's denominator is the product of the 2 factors' denominators. For example, 1/2 of 1/2 is 1/4. Multiply the denominator of the first factor by the denominator of the second factor. 2 times 2 is 4. Notice that the denominator in the product is also 4. Let's look at the second equation solved. Of 1/2 of 1/3 is 1/6. Multiply the 2 denominators. 2 times 3. The product is 6, and this is the denominator in the final answer. When multiplying unit fractions, the product of the denominators will be the new denominator. The objective for this lesson was to use visual fraction models to represent multiplication of a unit fraction multiplied by a unit fraction. We met this objective by representing real-world problems with an area model. We related the area model to mathematical equation and explored the relationship between the product and the factors.